Right. So in chapter 6, we're going to start talking about, more functions. We're going to get into some radical functions. And then eventually we're going to get into rational, fractional functions. Yep.
Why do they always use like f of x and g of x?
As opposed to like other letters or the notation. Those are just the more common ones. And then when we need to expand, we get into like h and, other things. Because it's like f for a function, I imagine like that, like a function of x. So that's where it came from. And then the next one will just be g because math people go in order.
And we use h and k.
Right. And then when we need to expand, we go into like h and k, sometimes l, and so, yeah. It's okay. We can live with this. Okay, so we've known for a while now that we can take two different functions and we can add them, right? So that's kind of what we're going to talk about today, but we're going to talk a little bit about notation as well. So if I have two functions, f of x and g of x, that's one way in the red that I can say, let's add the two functions, take f of x, g of x, and add them. Another way to write the exact same thing in more concise form is this, f plus g of x. That's what I want you guys to pay attention to. So here, this notation on the left, this isn't f plus g times x, this is still f plus g of x, right? So this and this, they mean exactly the same thing. And similarly, we can write a statement for subtracting them. So if I have this isn't f minus g and then multiply by x. No, this is just f of x minus g of x. All right? F times g, this should have an of x here. F times g of x, that's just f of x times g of x. And then f over g of x is the division. And of course, we have to make sure that the denominator is not 0. So let's take a look here. Yes. So here we have f of x and g of x. We need to find each function, and then we have to indicate restrictions on the domains. Yeah.
How do we know g of x isn't 0?
It's told you, like it's given, right? This is g of x, and then you'll have to find where it's not 0, right? So that's what we're going to talk about. Okay, so f minus g of x will be f of x, which is 3x squared plus 7x, minus g of x. Remember, that has to go in parentheses. So that's going to be 3x squared plus 7x minus 2x squared plus x plus 1. So that's going to be x squared plus 8x plus 1. That's it. Okay? So let's talk a little bit about, look at f of x, just f of x. What's the domain for f of x? The domain. All real numbers. What's the domain for g of x? And then what's the domain for f minus g of x? All real numbers again. Because it's a polynomial function, right? Look at f of x, 3x squared plus 7x, right? Is there any x value that when you plug it into f of x, you'll get undefined? No. That's how you know the domain is all reals, all right? Because any values of x work for it. Okay, now let's do f over g of x. That's going to be 1 divided by the other. Let me do this one and then I'll take your question. So this is going to be 3x squared plus 7x over 2x squared minus x minus 1. Okay? Now, when you have something like this, right, are you supposed to factor or not? So here's the answer to that. If by factoring the top and the bottom, you will be left with terms that you can cancel from the top and bottom, then you have to factor and you have to cancel things out and you have to simplify. But if by factoring you're not going to go any further and cancel things out, then you don't have to factor. Okay? All right. Before I move on, did you have a question? We have to see, are there any values of x for which the denominator is 0? So let's take that denominator and we have to factor it. Right? Remember factoring? Huh?
Why did
You have to factor because as soon as you realize you have variables in the denominator, you have to figure out for what values the denominator is 0. Okay? So you have to take the denominator, set it equal to 0, and factor it.
if there's so you always have to factor the denominator?
Yes.
And you always have to do that if there's a variable in the
Yes. So here, you set that equal to 0. So 2x plus 1 equal to 0, x minus 1 equal to 0. X is negative a half, x is 1. Okay, what do these, fine, we solved these. But what do these values mean in the context of this problem right here? These are the points where?
It's undefined.
Exactly. These are the points where the denominator is 0. That means the whole function is undefined. So when you write your answer here, you have to also say x can't be negative a half, x can't be 1. These are called the restrictions. Okay? So this is f divided by g, except x can't be these two values because you can't put anything that's potentially undefined. Yeah.
How would that look like on a graph?
You'll learn that in, so we're going to learn that in 7 or 8. I think it's 8, but yep, okay? All right, they're asymptotes. I don't know if you learned about asymptotes in Algebra 1, but those are where you get asymptotes. Okay, yeah.
We didn't do the restrictions for A.
Correct, because you said the domain was all real numbers. So there are no restrictions, right? Okay, so let's talk about composition of functions. Composition of functions are when one function is used to evaluate another function. In other words, if you have one function inserted or nested into a different function, all right? The notation for it is this. That's a circle, f circle g of x. Again, we read it as f of g of x, right? And it looks like this, f of g of x, right? F of g of x, all right? And that's how it's like written in concise form. So here we're going to write f of g of x and g of f of x. What this does is, you take g of x and you physically insert it into f of x, all right? And so on and so forth. So here's how we're going to do this. Is it a quick question?
Yeah.
Yeah.
If it's different letters, how would we insert them?
Okay, this is what we're going to do right now, okay? All right, so take a look here. The first one says, find f of g of x, right? When you have f of g of x, the first function or the outside function is f of x. So let's start with writing that first outside function. I'm just going to copy it over. F of x is negative 3x, right? That's the outside function. What I want to find is f of g of x, correct? So this is what I want to find. The reason why I started with f of x is because that's the outside function here. So now compare not the right side, just the left side, f of x with f of g of x. If I have f of x and I ask you to find f of a, what do? Replace x with a. So what happened in going from f of x to f of g of x? This time, the x got replaced by what? G of x. So in my function, I have a negative 3 times x. Every single x gets replaced by g of x. What is g of x in this problem? Negative x plus 8. So then f of g of x will be 3x minus 24. Okay? Now, we need to find the domain and range for each composed function. What's the domain of 3x minus 24? All real numbers? Because it's a polynomial function. There are no values of x that make this undefined. There are right? There are no roots to worry about, okay?
Can you not make it 0?
So this is what we learned in chapter 1 and 2, right? What does this function look like? When you graph it, what is this? It's a line, okay? So it exists over all values of x, and it exists for all values of y.
If there was like the degree was 3.
Right, still, any polynomial function where you have a variable with integer exponents, right? X to the 1, x to the 2, x to the, all of those are polynomial functions, and they have a domain of all real numbers. Okay? Yeah.
We just learned if something has like an odd degree, it would be all.
No, it would be all real numbers, right? An odd degree function looks like this.
Oh no, I mean an even degree.
Well, an even degree function, you mean the range or the domain? The range, right. Okay, so, okay, let's continue with this, and then I'll take more questions. Is it a quick one?
Yeah.
Okay.
So wait, isn't this just like y equals mx plus b?
This particular one ended up as a linear function, yes. Okay, now we're going to find g of f of x. This time the outer one is g of x, right? So let me just write that down, negative x plus 8. G of x is this. Okay, what do I need to find for this one? G of f of x. So look at what happened now. The x got replaced by f of x. So when I go in when I go into my function, I have a negative times what's x going to be replaced by? Negative 3x. Now remember to put that in parentheses though. Plus 8.
Why is there another one?
Because there's one negative here, and then there.
So only the x is being replaced.
Right.
Not like what comes
Correct. So now g of f of x, you have to simplify. That's going to be 3x plus 8. So again, take a look at your function. Okay, please hang on. Okay, take a look at your function, right? Ask yourself, are there any variables in the denominator? No. Are there any x's that are in square roots? No. That means if you just have variables with integer exponents, x to the 0, x to the 1, x to the 2, x to the 3, then the domain is going to be all real numbers, right? So here, the domain is all real numbers. Now, we're in Algebra 2 Honors. By the time we're in Chapter 6, we've learned about linear functions, quadratic functions, cubic functions. We know how each of these look. So this is where we need to see a bigger picture. Now I have a function here, 3x plus 8. If I was walking down the street and I saw a billboard, it was just a white billboard, and all it said on there is g of x is 3x plus 8, I would look at it and I'd be like, oh, that's a line, right? That's where we should be right now. So if I have a line, what's the domain? What's the range? All real numbers, okay? All right. Okay, yes, and then I'm going to pause questions for a little bit.
Maybe 3x minus 8 is negative.
No, because the negative only goes for the other negative 3x.
Oh.
Okay, so let's do some more here. So we're going to do the same thing, f of g of x and g of f of x. So again, I'm going to do it this way, one more, and then I'm going to show you a more efficient way as well. So here, this is f of x, right? Because when I do f of g of x, that's the outside one. Now, f of g of x, the x gets replaced by g of x. So x is now going to be replaced by x minus 6, then squared plus 2. Okay? So look, the x now became this, but then the x is squared plus 2. All right, let's multiply this out. X squared minus 12x plus 36 from the previous chapters plus 2. So f of g of x is x squared minus 12x plus 38. Okay? All right. Now, this is a polynomial function again. You have x's with integer exponents. The domain is going to be all real numbers. What's the range though? Is it 38? What does that parabola look like? Yeah. So now take a look at this. Where did this function come from? This function came from here, right? This is a parabola with vertex 6, 2, and it faces upward, right? So the range is y is greater than or equal to 2.
Is that what Sydney said?
Yes, that's what Sydney said. And we're very proud of her for that. All right, so next I need to find g of f of x. So g of x is x minus 6. G of f of x, now x is going to be replaced by f of x. So that's going to be x squared plus 2 minus 6. So g of f of x is x squared minus 4. Okay, now, again, this is a parabola, right? The domain is all real numbers.
Can you factor that more?
Well, you don't need to, though. You can leave it like this, okay? We don't need to factor them. Okay, so what does that parabola look like, though? We know exactly what it looks like. Y is greater than or equal to -4. Okay, now, the next one, I'm going to minimize it by 1 step. And if you don't want to do it that way, you don't have to. You can still keep doing it as write the f of x and then write f of g of x and replace. But let's go directly into this second step. Let's see if we can do that. So I want to find f of g of x. F of g of x. I look at this and I think to myself, g has to be inserted into f. So g, look up here, g has to be inserted into f, right? So it's, hang on, so it's going to be, this is f, I'm going to put g in there. So instead of x, I'm going to put in x cubed minus x squared. And then I continue and I have plus 4, right? And if you look at this, look, this red part was x plus 4, x plus 4. So that's the simplified version for f of g of x. Let's do g of f of x and then we'll come back and do domain. G of f of x. Now I'm going to take f and put it into g. So all of these x's here are going to be reply x plus 4, right? So I'm going to have x plus 4 cubed minus x plus 4 squared, right? I lost my color coding here. Okay?
I don't guess what to do now. What we did before.
Nothing. I just skipped one step of writing. Okay? All right. So here for the first one, what's the domain? All real numbers. Okay, now this is a cubic function, correct? So what's the end behavior going to be? Like it's going to go up on one side, down on the other side. So the range is going to be all real numbers. Okay? Here, domain, again, all real numbers. Why? Because all we have are variables raised to integer exponents. So the domain is going to be all real numbers. Okay. Now, it is when we multiply these out, eventually we're going to get x cubed. Cubic function. So we're still going to get a range of all real numbers. Huh? Just because I don't know if I'm going to have more time. I might come back to it later. Okay? All right. So let's go back here. Yep.
We're supposed to like keep it on a test or
Yep. Okay, but I'll come back to it in a little bit. Okay, so so take a look at these. G of h of 2. Now we have values inserted in these, right? It's no longer g of h of x, right? Now we have a value inserted in here. So there are obviously, like anything else in math, way more than one way to do it. I'm going to show you one way, which I find when it's something like this, the most efficient way to do it. What you can do, but we're not going to do it, is you can still find g of h of x and plug in the 2. But that ends up being a much more, like a longer process. Then here's what we're going to do. Always start from the inside. I'll tell you, it's not a secret. Give me a little bit of time. Start from the inside. So the inside of this is h of 2. So find your h function. H of 2 is 2 squared minus 1. Why? Because that's how we've been doing it since chapter 1. We're moving past that now. H of 2 is 3. Now go back out. The outer part is g of h of 2. So g of 3. And that gives you 3 times 3 minus 1, 8. Okay, let's do it again. F of h of 3. I start from the inside. H of negative 3 is negative 3 squared minus 1. That's 8. F of that number 8 is, where is F? 2x 16. All right? Okay. Here, start from the inside. F of a plus 1. F of a plus 1 is, this is why we were doing all this stuff in the previous chapters, right? They weren't because, you know, we just felt like it. 2a plus 1, right? Because it's 2x. So that gives me 2a plus 2. Yep. Yep. So now I'm going to go on the outer part and I'm going to do what of what? H of 2a plus 2. So I get 2a plus 2 squared minus 1. Okay, here's where many of the mistakes on the test usually come in. We have to square this, and you're going to get how many terms when you square that? 3 terms. And they're going to be 4a squared. What's the next term? 8a. Because it's 2 times 2a plus 4 minus 1. So it's plus 3. Okay, the next one has 3 of them, right? So we start from the innermost one. That's h of 0. What does that give me? Negative 1. Then I go outside. That's 1 level, right? That's g of what? Negative 1. And that will give me negative 4. And then I go out again and I get f of negative 4. And that gives me, yes.
I have a question.
Yeah.
So would the answer for all of would all the answers be negative 1, negative 4, negative 8? Is there 3 answers?
No, there's one answer.
Oh,
There's one answer. The answer is just this. Okay, right now I'm going to give you a minute to do E, please. First one. So, f of negative 2 was what? Negative 4. Oh my God. Come on, man. Work with me here. And what's f of negative 4? Right? And then what's h of 63? Right. Okay. Raise your hand and tell me what you got for the next one. Leah.
60 squared minus 6.
But you forgot the minus 1 on the outside. 6c squared minus 7. Anybody else get a different answer? Let's do that one. Yep.
For this one, would you still say g of x of h of c?
Yeah.
Even though
G of f of h of c. Yeah. Even if there is parentheses, it's the same. It's nothing. That's the associative property. You can put parentheses when you have a series of 3 things wherever you want.
You copied all the question and the equals.
Well, you like to show work?
Like for the final answer.
Yeah, the final answer is just this.
So could we do it this way?
There are no 3 answers. The other ones are just the work.
No, but do you say G of F of H of C is the answer?
Yeah. Oh, I see. You don't have to. So H of C is this, and then F of C squared minus 1 was what? 2C squared minus 2. And then G of that, 6C squared minus 7. So that's technically the answer, right? If you give me 3 different answers for these, like if you'd say the answer, like on the answer space, -4, -8, 63, that's wrong, right? It's just the last one. The other is the work. Right. Yeah. Okay.